Okay, so we have some triangle basics here. We're going to discuss the Triangle Sum Theorem and the different types of triangles. You have scalene, isosceles, and equilateral triangles. So we have the Triangle Angle Sum Theorem. That simply states that the measures of the angles of a triangle equal 180 degrees. All triangles have angle measures that equal 180 degrees. So we have an example here. If we add 120 plus 40 plus 20, that gives me 180 degrees. And so all triangles, the three angles, always add up to 180 degrees. Another example, if this is 60, and this angle is 40, that third angle would have to be 80 because 60 plus 40 is 100 and 180 minus 100 will give me 80 degrees. So all angles equal 180 degrees in a triangle. So the first type of triangle we have here is called a scalene triangle. And with a scalene triangle, you have no congruent angles and no congruent sides. So as an example, I could have side lengths 5, 7, and 10. Because none of those sides are equal, that would be considered a scalene triangle. There are also no congruent angles. So remember, all angles have to equal 180 in a triangle, but in a scalene triangle, none of the angles are equal. Next, we have an equilateral triangle, and we see the root word here, equal. So that means that all sides and all angles are equal or are congruent. So since we already know that there are 180 degrees in a triangle, if you have an equilateral triangle, it's also equiangular. All angles are equal, so they always have to be 60 because the angles have to equal 180 and all sides have to be equal. So in an equilateral triangle, if this side is 10, this side would also be 10, and then the third side would also be 10. So equilateral, root word equal, all sides and all angles are equal. Okay, so the last triangle we're going to discuss is called the isosceles triangle. And that is basically a triangle with two congruent sides, or two sides that have the same length. And these sides are called legs. So the two sides that have the same length in an isosceles triangle are called legs. And it is denoted here, or shown here by these congruence marks, meaning that they have the same length. All right. And then we have the vertex angle. That angle is in between the two legs, and so our vertex angle is right here. And as you can see, it is right in between the two legs. And then we have base angles, and these are angles that are opposite the legs. And so we have our leg right here, and then a base angle here in red, and then another base angle here in red. These are opposite of the legs, and they are also congruent or have the same measure as well, and that's denoted here by these arcs. So you got two congruent sides and two angles with the same measure with an isosceles triangle. And now we have the base. That is the side between the base angles. So kind of easy to remember. You have your base angles here, and then the side that is in between them, which is right here, is called the base. So there we have the different parts of an isosceles triangle. Okay, so with an isosceles triangle, we have two theorems. We have the isosceles triangle theorem. So that basically states that if two sides of a triangle are congruent or have the same length, then its base angles are also congruent. So if we look at this top figure here, or this triangle here at the top, we have sides AB, and AC that are congruent, and we know that because we have these congruence marks that I'm highlighting. So we can conclude that angles B and C are congruent as well because they are opposite those legs, and so they have the same measure. And then we have the converse of the Isosceles Triangle Theorem. That basically states that if two angles of a triangle are congruent, then its opposite sides are congruent. All right, so if we look here, we see here that the angles F and E have the same measure. So we can conclude with this theorem that side FM and side EM are also congruent. All right, and so those are the basics of triangles. So now let's analyze these three types of triangles. Okay, so let's take a look at these two triangles here. All right, so what type of triangle is this? Well, we have two congruent angles here. Therefore, we can conclude by the isosceles, or the converse of the isosceles triangle theorem, that their opposite sides are congruent. And remember, the congruent sides are called legs within isosceles triangle. And so what we want to do, we want to find the value of x and find the length of each side. So in order to find the value of x, since I know that these two are legs and they are congruent, I can simply set these two expressions equal to each other to find x. So I have 5x minus 3 equals 3x plus 7. Using my inverse operations, positive 3x, I'm subtracting 3x, cancels out. 5x minus 3x, 2x, bring down a minus 3, and the 7. So now I'm just left with a two-step equation. Inverse of minus 3, add 3, bring down my 2x. 7 plus 3 is 10. Divide by 2, x equals 5. Now since I've solved for x equals 5, to find the length of my legs, I could simply plug it in for x up here. So I have 5 times 5, because x is 5. I'm plugging that in. 5 times 5 is 25 minus 3. And so the length of that side is 22. So what can we conclude about, so the length of side AB equals 22. What can we conclude about the length of this side? Well, if they are congruent, we can also conclude that the length of side AC is also 22. But to check our work and to make sure that we found the correct x value, I'm going to plug it into here as well. So 3, I'm plugging in 5 for x, plus 7, and that's 15 plus 7, and yes, I do get 22. So it's good to plug it into both to make sure that you got the correct x value. And so now this is going to be my base. It's not going to be the same length because only my legs are congruent with an isosceles triangle. So this is 6x minus 3. I'm just going to plug in my 5 here. So 6 times 5 minus 3. That is 30 minus 3, which is 27. So side BC is 27, and I should have been putting inches. This is in inches. All right, so we found the length of each side of this isosceles triangle. We were able to conclude that this is an isosceles triangle, and we've analyzed this triangle. Now let's analyze this triangle right here. So we see that we have 3 congruence marks. So what can we conclude about this particular triangle? Well, since we have 3 sides that are congruent, we can conclude that this is an equilateral triangle. Equilateral triangle, so all sides are congruent. So Since all sides are congruent, we can conclude that all of these angles are congruent as well. And so since there are 180 degrees in a triangle, we know that each angle would have to be 60. All right. So now we want to find x and y. In order to find x and y, since we know that this angle is 60 and this angle is also 60, we can simply set this expression, x plus 5 equal to 60, to find x. So that's a one-step equation. Just subtract 5, and 60 minus 5 is 55. So x is 55, and to find y, we do the same thing, set it equal to 60, and we know that it equals 60 because this is an equilateral triangle once again, and all angles are also equal or congruent. And so we add 10, one-step equation. So y equals 70. And so we've analyzed this equilateral triangle. So let's analyze this triangle here. All right, so it does not give us any marks or congruence marks to show that any of the sides or any of the angles are congruent. But what we can do, we have three expressions here for our angles. We can actually find the value of x using the Triangle Angle Sum Theorem. And remember that all three angles added together in a triangle always equals 180 degrees. So angles in a triangle equal 180. And we know that because of the Triangle Angle Sum Theorem. And so in order to find x, we could simply add all of these expressions, or add these expressions together, set it equal to 180 to solve for x. So let's do that. So 8x minus 11 plus 15x plus 3x plus 9. And all together it equals 180. All right. So now in order to solve for x, we want to combine our like terms, 8x, 15x, and 3x. So we just add our coefficients, 8, 15, and 3. So 8 plus 15, that is 23. And 23 plus 3 will give us 26. So that is 26x. And our other like terms are the constants because they don't have variables. Negative 11 plus 9, that is negative 2. And I bring down that 180 degrees, or 180. So now I'm just left with the simple two-step equation, adding 2. So that's my inverse operation. Bring down my 26x. 180 plus 2 is 182. And dividing both sides by 26. And 182 divided by 26 is 7. So I found that x equals 7. So since we know that x equals 7, we could find the measure of each one of these angles. All right, so let's see. 15x. So that would be 15 times 7. All right, and 15 times 7. Can't think of it right off the top of my head. Let me get my calculator. Calculator. That is 105. All right. All right, and so now we got 8 times 7 minus 11. That gives us 56 minus 11, which is 45. So we got 45, 105. And then we can do 3x, or 3 times 7, plus 9. That is 21 plus 9. That gives us 30. So we got a 30-degree angle, a 105-degree angle, and a 45-degree angle. Now to check our work, what should they equal? Well, they should all equal 180 degrees. So let's check it. 105 plus 45 plus 30, that in fact is 180. So we've analyzed this triangle. We concluded that we could find our angles, and since we don't have any congruent angles, meaning we don't have any congruent sides, we can also conclude that this is a scalene triangle as well. And so we've analyzed this triangle.